Hey everybody, sorry, my camera cut out, I guess, and I didn't realize it. So I went a little bit ahead by myself, but that's okay. So if we're looking at these coefficients for elasticity, I put the incorrect thing up there. I didn't realize it said perfectly inelastic. If we're looking at this coefficient, we're looking at the relationship of the change in quantity and the change of price. If I raise my prices, what's going to happen to the quantity demanded? If it's perfectly inelastic, that means people are going to keep buying the product regardless of the price. So if I raise my prices by 10%, but my quantity doesn't change, if it's zero, well, zero divided by anything is going to be zero. So the coefficient for something perfectly inelastic is going to be zero. If it's relatively inelastic, it's going to be less than one, because that means that relationship's small. So if I raise my prices by 30%, but only 10% fewer people buy my product, 10 over 30 is going to be a third. So that coefficient would be less than one. If we're looking at it being unit elastic, that would mean that there's not going to be an effect, right? That if my prices, because we're looking at the change in quantity over the change in price, if my prices go up by 10% and my quantity demanded goes down by 10%, that coefficient's going to come out to 1. Now, it'll be negative 1 because we're looking at demand, and demand always has a negative relationship. If we did it with supply and price went up by 20% and quantity supplied went up by 20%, that would come out to 1 as well. It would be unit elastic. Now, if something has an elastic demand, then it's going to have a coefficient greater than 1. That means that a small change in price is going to have a big impact on the quantity demanded. If my prices go down by 10%, but quantity demanded goes up by 20%, my coefficient would be negative 2. And again, we care about that absolute value there. That the absolute value is greater than 1, that means that there's going to be a big effect. And then finally, for something to be perfectly elastic, again, what we're seeing here is that if we change the price at all, our quantity demanded drops to 0. So we could raise our prices by 20%, but the quantity demanded would be 0, or the change in quantity demanded would be 0. Anything divided by 0 isn't a number. Some people just use like the infinity symbol here, which I can't really draw. I just do sideways 8, like an invalid number. But the main one that we measure for elasticity is this total revenue test. It's this idea that if a business has an inelastic demand for their good, they do have control over prices. Think back to that Daraprim drug. They knew they could raise their prices because it's a life or death pill for people with HIV. And so by raising their prices, total revenue goes up. They have no incentive to lower their prices because if they did, they'd lose money. Whereas if we're looking at a good that has an EpiPen did the same thing. They raised their prices by like $50 because they knew that people would keep buying it. But for most goods, we would have an elastic demand. Think back to the gas stations here. If we're looking at that corner with the Wawa and the other two gas stations, if one of them raises their prices by 50 cents, their total revenue is going to go down. No one's going to buy that product because they've got two neighboring competitors. Whereas they all have an incentive to be the cheapest one, because if they lower their prices, their total revenue is going to go up. More people are going to buy their product. Now, if we're looking at the cross-price elasticity, we're just looking at the relationship between two different goods. We're looking at the change in price, the change sign, the delta sign, the triangle just means change. The change in price of one good, let's say good A, under the change in quantity of another good. So we're saying that, okay, if the price of good A, let's call them hot dogs, goes up, what's going to happen to the demand for good B? If hot dogs get more expensive, fewer people are going to buy them. If hot dogs get more expensive, fewer people are going to buy them. More people are going to buy the burgers by comparison. So we're looking at our quarter pounder still, but we're looking at the change in price of one good affecting the change in quantity of another. And sorry, that's answering question 2 there. If we're looking at this cross-price elasticity, we're just comparing the demand coefficient between two goods. So if we're thinking of, cars and trucks, they'd be substitute goods. If you're buying a car, you're less likely to buy the truck. If you buy the truck, you're less likely to buy the car. If they're complementary goods, you buy them together, right? If you buy that French fry from McDonald's, you're more likely to buy the drink or the burger as well. If we're looking at this range here, it's just to kind of give you a visualization of it. if we're looking at it being, because here we are looking at a positive and a negative value, right? So it's kind of hard to see on here. So we're looking at the change in quantity of one good and the change in price of another. So if the hot dog gets more expensive, let's say it gets 20% more expensive, and the quantity supplied of the burger goes up by, let's say 30%, well, that coefficient is going to be positive. A is getting more expensive and people are buying less of it. At the same time, more people are buying B. In this case, they'd be substitute goods, right? If that coefficient's positive, they'd be substitutes. If the coefficient's negative, that means that they're complementary goods. If we think back to the hot dog and the buns, if the hot dogs get 20% more expensive and people buy 20% fewer buns, well, that coefficient's going to be a negative. They'd be complementary goods. And the final one for our elasticity is the income elasticity. Again, this one I think is pretty simple. We're just looking at the relationship of income and quantity demanded. So what this is saying is that if we're looking at this down here, if our income goes up and our quantity demanded for a good goes up, that's going to make it a normal good, right? That we're buying more of it, our income goes up. Or sorry, we're making more money and we're buying more of it, our income goes up. Or vice versa, that if our income goes down, we're buying less of this good. That would also make it a normal good. Negative divided by negative is still positive. Now, if we're looking at inferior goods, that coefficient's going to come out to the negative, right? We're looking at the change in income and the change in quantity demanded here. So if our income goes up, and let's say we're looking at ramen noodles, and our quantity demanded for those noodles goes down. Our income's positive, quantity demanded is negative. Negative divided by positive is going to be a negative. So with that income elasticity, it's always going to come out to a negative coefficient.